Hello students, myself Janil Popat. We are discussing shear strength of soil. This is video part 4. In previous 3 videos, we have seen basics of shear strength, shearing resistance mechanism, Mohr's circle theorem, as well as Mohr-Coulomb, as well as Mohr modified theories, as well as some experimental techniques like direct shear test, UCS, as well as triaxial shear test. Now, we should understand numericals of this chapter too. For this, you have to remember all the concepts as well as formulas in this chapter. Let us start with numericals. In previous video, we have seen one numerical. Let us skip that and we will go to second problem directly. Problem 2. Two drained triaxial tests are performed on the material. So two tests which are triaxial are performed. In the first test, the all-round pressure is 200 kilonewton per meter square. So all-round pressure is given and failure occur at an added axial stress of 600 kilonewton per meter square. Now, they have provided 200 kilonewton per meter square all-round pressure and extra axial stress, which is added axial stress, which is 600 kilonewton per meter square. Keep in mind that in the second test, all-round pressure is 350 kilonewton per meter square all-round pressure and failure occurs at an added axial stress, which is 1050 kilonewton per meter square. Now question is, what values of C dash and phi dash correspond to this result? So we need to find C dash and phi dash first. For that, let us write out given data first. Here you are provided with sigma 3, sigma d and sigma 3 and d for sigma second test. Right, first test and second test. So for first test, sigma 3 is given as 200, which is all-rounder or cell or confining pressure, and sigma d deviator stress, that is 600 kilonewton per meter square. So sigma 1 is total of both, right? Sigma 1 is sigma 3 plus sigma d, so it will be 600 plus 200, 800. And for second test, sigma 3 is given as 350 kilonewton per meter square. Sigma d deviator stress is given as 1050 kilonewton per meter square. So sigma 1 becomes of total of both sigma 3 and sigma d, or we can say sigma c plus sigma d. It will be 1400 kilonewton per meter square. So both the test cases are different. Now the formula or equation to remember for triaxial test is sigma 1 is equal to sigma 3 10 square alpha plus 2c 10 alpha. This formula is given from triaxial test and we have to remember it to solve numericals. Now sigma 1 and sigma 3 are related with alpha as well as c. So let us write values from first case first here. So 800 sigma 1, sigma 3 200, 2c plus 2c into 10 alpha is unknown, so I have put it like that only. Now from second case I can get the same equation like 1400 is equal to 350 10 square alpha plus 2c 10 alpha. Here alpha value will become 63.43 degrees after solving both the equations. So you have to solve these both equations to get alpha. After getting alpha, I am putting value of alpha in equation 1 or equation 2, whatever you like. You will get the value of phi. Phi value will be 36.86 degrees. Now putting phi value in the equation, you will get C dash as 0. Here alpha will be 40 pi plus phi by 2. So you can find the equation from that. So after getting all these values, we have to plot the graph and check the value. So plotting the graph between shear stress versus normal stress. I will plot it like that. If for case 1, in the first test, sigma 3 is 200. I will start my graph with sigma 3 200, as we have learned in Mohr's circle of stress. So I will start first graph with 200 and it will end up to sigma 1 of that case. So sigma 1 is 800 for that case. So it will go from 200 to 800. And same way in the second case, the graph will start from sigma-3 in the second case, that is 350, and it will end up to 1400 kilonewton per meter square. So these two graphs will give a same tangent, and that tangent will give me the phi value. So I should check the value of phi from there too. Putting phi and alpha and c values in the equation, I can get all the values. So I should check the values from same from this theory. Now you can just simply check that here from analytically C dash is coming 0. So the constant cohesion is 0, and in the graph also you can see the cohesion is 0 because the tangent is starting from 0. So this is the basic idea of this numerical. Let us move to second numerical, that is problem number 3. UU test was conducted on a soil sample, unconsolidated, undrained test. The following results were obtained. Determine shear strength parameters with respect to total stress and check your answer graphically too. So test results are given like that. Cell pressure and deviator stress are given 100, 65, 200, 132, 300, 200, and we have to solve the problem. Also check it with graphical method. So let us start. It is a similar kind of problem. Here we will use formula sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. Now putting the equation in a table form. So cell pressure is 100, deviator stress is 65, so sigma 1 will be 165 for the first case. For second case it will be 332, third case it will be 500. So this is how we can plot a table also. Now we will give a name equation 1, equation 2 and equation 3. Now solving any of these equations, we will get phi 14.52 degrees and c is equal to 0 again. So this is analytical value. We have to also check graphical values. So we are plotting the graph again. The graph will go as I have explained in the previous problem, same way, start from 100 to 165, 200 to 332 and 300 to 500, and the similar tangent line will be plotted, and that will give you alpha and c value. From phi you can also calculate alpha value. So we can simply just check that right now, as we are not having original graph paper here. C value is 0 analytically, as well as in the graph C is provided 0. So your test results, your results of calculation will be 100% right. Let us move to problem 4. Following are the results from a box shear test, that means direct shear test. Determine the values of C and phi if a specimen of the same soil is tested in a triaxial apparatus. So same soil specimen is tested in triaxial apparatus too. Estimate the deviator stress at which the sample will fail. So I have to give deviator stress now when the cell pressure is 100 kilonewton per meter square. So here is the given data. Normal stress when it is 25, shear stress will be 60, same way 250, it will be 155. So these are values obtained from experimental data. Okay, from this data we can do one thing very much easily, that is we can plot a graph. So we are plotting a graph of normal stress versus shear stress. So it is happening like this, and one line is coming from which, from graph, I can get the value of C as 50 kilonewton per meter square and phi is equal to 20 degrees. After getting C and phi, I will go and analyze this analytically. So sigma 3 is given 100 kilonewton per meter square. Alpha will be found out 45 plus 5 by 2. 5 we already have it from graph, that is 20. So alpha is equal to 55. Sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. That is the basic formula for this triaxial test. I will put the values on that. So sigma 1 is equal to 100 tan square alpha plus 2c tan alpha. Here I know c and alpha both. So I am putting all values in this, and I am getting sigma 1 as 346.77 kilonewton per meter square. So this is my sigma 1 value. This is total stress, but I need only one type of stress, which is deviator stress. So I have cell pressure. So I will remove cell pressure from this. So I will get sigma 1 minus sigma 3 is equal to 246.77 sigma d, that is deviator stress, which is asked in the problem. So that's it for this problem. Let us move to next numerical, problem number 5. For a triaxial shear test conducted on a sand specimen. So triaxial test is conducted on a sand specimen at a confining pressure of 100 kilonewton per meter square. So sigma c is given as 100. Under drained condition resulted in a deviator stress, which is sigma 1 minus sigma 3 at failure of 100 kilonewton per meter square. So you are told to find out deviator stress at failure, that is 100 kilonewton per meter square, and find out angle of shearing resistance. So you have to find angle of shearing resistance. So basically we need to find angle of shearing resistance, that is phi. Let us solve the problem. Here I have been provided sigma 3 value, that is cell pressure value 100 kilonewton per meter square, as well as I have been also provided sigma d value, deviator stress is also having value as 100 kilonewton per meter square. So I have to find out sigma 1 from that. So sigma 1, making sigma 1 as a subject of the equation, I will get sigma 1 is equal to 100 plus sigma 3. Now sigma 3 has been given. Putting both the values, I am getting sigma 1 as 200 kilonewton per meter square. Now from sigma 1 I can get alpha, because this is sand, and in sand cohesion will be 0 by default. So C will be 0. Putting equation sigma 1 plus sigma 3 10 square alpha plus 2c 10 alpha, value C is equal to 0, and sigma 1 as 200, sigma 3 as 100. I am getting alpha value as 54.73 degrees. Now I got the alpha, so I can find out phi 2. For phi, I will use the equation alpha is equal to 45 plus phi by 2, and I am getting phi value, angle of shearing resistance, as 19.46 degrees. So that's it for this chapter. All the numericals should be practiced so that you can easily understand numericals as well as experimental portion of this chapter. Thank you.